Welcome to a not so fun topic here. This is 7.1 air pollution, but extremely important, especially for us anywhere in the world, living in Korea, living in LA, living in Denver, living in London. Air pollution is becoming a big issue. So let's talk about it. All right, what do we consider this air pollution and what is it caused by? So air pollution is caused by the burning of fossil fuels. We've talked about fossil fuels before. That can be anything from coal, gasoline, diesel, natural gas. And all of these things they're called these hydrocarbons. Hydrocarbons meaning they have a hydrogen and a carbon in them. And when we burn these hydrocarbons, we have noticed that they are producing things that is making our air quality a lot worse. Okay, let's talk about coal. Coal was formed a long time ago in ancient swamps. We're talking so long ago that these were the main things that covered the planet. We didn't have a lot of our tectonic movement yet to create our mountains. And so most of the planet were these ancient, old, swampy environments. So then trees grow and they take in all this carbon into their bodies. They're growing, and all of a sudden they die. So they die into these swamps here. And these swamps are not a great environment for bacteria. There's low oxygen, there's no bacteria. And so they just kind of die and there's nothing to decompose them. So they just stay there. And then over millions and millions and millions of years, they get crushed as more layers of trees fall on top of them. This general state is called peat. With more heat and more pressure, we turn into brown coal, which is not very good coal. They don't really use a lot of brown coal. But you can see again, this heat and this pressure is squeezing this water out. So it's squeezing these molecules and kind of breaks things apart, but yet there's so much carbon in here. Then over so much heat and so much pressure, we're going to get black coal. Black coal, there's three different types of black coal. The shiny stuff, the beautiful stuff that most of the world uses is this anthracite coal. That is what is used. That's if you ever see train cars carrying those big chunks of coal inside of them, that shiny black material, that is this anthracite coal that we are most often using to add heat into our homes. So then we're going to take that coal and we're going to make electricity out of it. In order to do that, we're going to take our coal in, and this coal is used to heat up water. Our goal is that we can burn this coal. It's going to produce a lot of heat, and that heat is going to take water through a turbine that's going to spin around a magnet, and as it spins, it's going to create electricity, which goes off to the houses. Unfortunately, coal has some nasty bits to it. It has sulfur. It has heavy metals. There's lead in there. There's mercury in there. So again, we do have some issues. And when we burn it, we may see that pop up in the air. Let's compare that with gasoline or petrol. Gasoline, also we call it diesel, natural gas. These are all things that they're derived from oil. Oil's different from coal. Coal was formed in swamps. Oil is formed in the ocean. When dead plankton, a lot of time it was zooplankton, phytoplankton, in the oceans, when they die and they go down to this area down here below, that's because it's no longer in the photic zone. There's not a lot of oxygen down here. There's not a lot of bacteria down here. And so they're buried in these layers. Now, I know this shows like octopus and seahorses. Like I said before, it's pretty much just zooplankton is what's creating the massive amount of this gasoline and petrol and diesel and so and so. So then, over time, again, just like before, layers and layers, pressure and pressure builds up over millions of years, and then we drill it to get our oil and our gas. This comes out as something called crude oil. When you look at politics, often crude oil is mentioned, especially in the Middle East. But that's what they're talking about. And then they'll distill that to make it into other great things that we need. Okay, so that crude oil that's coming out, it is a mixture of many different hydrocarbons. We've talked about hydrocarbons. These are examples of hydrocarbons. You can see it's carbon attached to hydrogens over and over and over and again in these massive chains. This is different again from coal because coal is just carbon. There's no hydrogen attached to it. So when we have this mixture of crude oils, our oil refineries are going to separate these based on the length of carbon chains. Those of you in AP Chem, they're separating these based on intermolecular forces. Now, all of these together can be called VOCs, which is volatile organic compounds. Anytime you smell fumes, whether it is formaldehyde, whether it is paint thinner, whether you're getting gas or petrol or diesel for your car and you smell those fumes coming off of it, even in the chemistry labs when we open up the methane taps, those are VOCs, and those have a big impact on air pollution, which we're going to talk about next. So our VOCs are like 1 to 3 carbons. That's going to be natural gas, and that's what's used for heating, for cooking, for electricity. It's a little bit cleaner than the gasoline and the diesel, which is a larger carbohydrate chain. But either way, all of this leads to the production of VOCs in the atmosphere. So then we have all of this. We have our coal, we have our VOCs, and then we burn it. We combust it. That's the whole purpose of having these fossil fuels is we're going to combust it. So coal, when we combust it, it gives us CO2, a greenhouse gas. Gasoline, when we combust it, we get CO2 and H2O. And then natural gas, when we combust it, we also get CO2 and H2O. This is what should happen. However, often it is not happening. In order for those reactions to go on, we have to have enough oxygen in this ideal ratio. When we don't, though, the combustion still happens, and it produces this horrible toxin called carbon monoxide, which is CO. When this happens, we say that we've gone through incomplete combustion. And so therefore the CO2 was not completely formed. We also had this CO. Now, carbon monoxide is extremely dangerous. It is what we call an asphyxiant, and it doesn't have any smell. So it's actually very hard to detect as one of the VOCs. This asphyxiant is taken up by the hemoglobin in our blood, and it actually blocks the blood from carrying O2. So we eventually die by these high levels of CO, and they cause neurological problems, and often they cause death. This happens over and over again in the basement of a house. Doot, doot, doot. Because that is where normally the heater is down there. And it produces, if I'm sleeping in a bed here, it produces out this carbon monoxide, which can be quite dangerous. So it's very important that if you're ever staying in a basement or living in a basement, that you have these carbon monoxide detectors, because it can be extremely dangerous for the body. So in addition to our VOCs, in addition to our carbon monoxide, in addition to carbon dioxide, we've also found that other pollutants are entering into the air because of combustion, and especially combustion at very high temperatures, which happens in cars and in motor vehicles. What happens is our air is going to come into the engine. Unfortunately, air is composed of both nitrogen and oxygen. The only thing we need is that oxygen, but the nitrogen's also going to come in. And then we're going to have this high temperature combustion happening. And then on the way out, it's going to cause these nitrogen oxides. We're going to reference them as NOx, knowing that that could be NO2 or it could be NO, or sometimes it could even be NO3. These compounds, these NOx compounds, are the major component of smog. We're going to talk about smog later, but they are the major component. They're going to give this brownish color, and they create something that's very dangerous, which is ground level ozone. Ozone is great for us when it's high up in the atmosphere, but it is not good for us when it is on the ground level. It causes eye irritation, it causes lung problems, and it's a big issue. There's actually a lot of deaths that happen in the world because of this ozone. And then the last one we're going to talk about is sulfur dioxide. As I mentioned before, coal and diesel, they both have a lot of sulfur in them. And so unfortunately, when they're burned, they produce sulfur dioxide. This is the main source of acid rain. We're going to talk about acid rain later. But this also causes a lot of irritation to the eyes, irritation to the mucous membranes, and therefore can really cause some lung function issues and some damage in the lungs. SO2 is produced most often when people are driving with diesel that is fueling their cars. So always go ask your parents, what do we put in the car? If it's diesel, we need to be a little bit more careful. Now, as I mentioned before, the NOx's, they help form ozone at the ground layer. Ozone is so beneficial in our stratosphere because it blocks that UV light that's hitting us. But at this ground level, it is causing severe irritation of the throat and the lungs, and has a profound effect on anyone with lung conditions, anyone with asthma, anyone with bronchitis, anyone with emphysema. It's extremely dangerous. In Korea, last year, we had 21,000 people die of air pollution, and most of that is from this ozone. Now, we consider ozone a secondary pollutant because no one is actually putting this ozone into the air. However, it is forming when our NOx, our nitrogen oxides, react with our VOCs. So here's a great image here that kind of walks us through what happens. Our VOCs are in the air, our nitrogen oxides are produced, and then the sun hits us, and that sun combines all of these together, causes this chemical reaction to form, and the product is O3 and something called PANS. We're going to talk about PANS a little bit later. So by having excess nitrogen oxides and excess VOCs, we therefore increase the amount of O3 and PANS that are being produced. Just real quick, primary pollutants, these are things that we are putting into the air. Secondary pollutants, these are things that form when the primary pollutants undergo chemical reactions. Now, I want to take us back to these VOCs real fast. We talked about VOCs. We haven't really got into a lot of detail about them. You can tell there's a VOC when you smell something. Whether this, as I mentioned before, if it's paint, if it is aerosols, if it is formaldehyde, if you smell something when you're putting gasoline in the car. All of those are examples of VOCs. In addition, plants also produce VOCs. So it could be produced from them, and even more, cows. Cows produce a lot of methane, which is another VOC. And all of these VOCs can react with our nitrogen oxides to form that ground level ozone. Okay, I'm sure y'all living in Korea have heard of things called PM 2.5s. We talk about PM 10s, we talk about PM 2.5s. That number there is the size of the particles in microns. So is it a 2.5 micron particle? Is it a 10 micron particle? But anyway, there are these tiny, tiny particles and little droplets that we can inhale into our lungs, and then they enter the blood, and then they enter the organs, and they can have dramatic effects in our body. These PM 2.5s are not always pollutants. They can come from just little dust particles that are up in the air. So we can get it from soil. We can get it from sea salt. We can get it from soot from all these factories. Forest fires are another example. Sometimes you see these particles falling in the air with forest fires. Or construction materials. If you happen to be living near a construction site and there's a lot of dust and soil being kicked up into the air. All of these can contribute to these PM 2.5s or these PM 10s. Then these particles mixed with weighted values for all these different particulates like VOCs and sulfur dioxide and nitrogen oxides, all of that then comes together to form the air quality index. KIS reports on this every single day. They actually have a air quality tester on site that will report the data for the air quality index that day. As I'm sure you know, these numbers go from 0 to 500, with low numbers being healthy, high numbers being very unhealthy, and even going all the way up to hazardous. And this is all composed of these 5 different pollutants. So our ground level ozone, our carbon monoxide, sulfur dioxide, nitrogen dioxide, and just little particles, our PM 2.5s or our PM 10s that are all floating around. All right, fantastic. That's a wrap. Thanks, guys.